Hi Gemini, good morning. Could you please provide enthalpy change information and give easy notes about endothermic and exothermic reaction with sort of images that can have, in fact, the energy profile diagram for endothermic and exothermic reactions. Make sure that you include some mnemonics for my students so that they can learn easily.
So you're at IB curriculum?
It will give enthalpy change.
So where's the lemon?
Where?
There's some lemon.
And then let's search. Okay. So you could see, hello, I would be happy to break down these two chemical concepts for you. Yes or no?
Yes.
Mnemonics also came out. Paste. So here the tools, I just need to change it. Earlier I used just guided learning so that I got it the mnemonics and trick. You can see here. This is the trick given from the AI. So I just need to select, okay, I selected canvas, I search it and it will make the PowerPoint presentation based on the topic. Okay, now the PowerPoint is getting made from the AI. I wanted to create. Can you see now? And instantly it is being created. You'll see here in your laptop, export to slides, so that you can easily modify it based on your needs. Okay, it's done now. Can you see? I didn't do anything. A beautiful PowerPoint presentation is being created. It's about energy of chemistry, exploring exothermic and endothermic reactions. So you can see here the concept of enthalpy that I was looking for here. There are some diagram also is being added. You can see the diagrams for the exothermic reactions. I think this is about endothermic reaction with the beautiful diagrams. Can you see all of you here? What is endothermic reaction, Irene?
Entering of heat. Sorry.
Endo means energy will be being absorbed, right?
Yeah.
Exo means?
Energy being released.
It's very good. Export to slide and then you will be seeing bigger one. Have a look. I think it is down, right? Let me open the slide. Now all of you, for a while you can just stop using your laptop. Look at here. We'll explore about this topic. Alright, all of you. Darren, can you read this heading?
Energetics of chemistry, exploring exothermic and endothermic reactions.
Okay, exploring exothermic and endothermic reactions. This is the defining things from this topic. How the thermodynamic focus. Enthalpy is the measure of total heat contained in the thermodynamic systems under constant pressure. Okay, equation is being given here. This is about exothermic reaction. So exothermic reaction means what? Irene, what is exothermic reaction means?
Release of energy.
Exothermic reaction. Release of
Energy to
energy.
surroundings.
Or else we call it heat energy being
Release. Exit.
given out, right? Yes. Given out. Very good. So exothermic reactions process where energy is being released to the surrounding, usually in the form of heat or light. Yes? So common characteristics include here the surrounding increases in the temperature, containers feels hot to the touch, chemical bonds formed are stronger than those broken up. Exothermic will be this side. So we are going to do profile diagram, energy profile diagram, okay? Energy profile diagram. So this is the energy profile diagram. This is the two-dimensional structure, x-axis and y-axis. Yes or no? X-axis represent what? Ishalna. Progressive reaction, right? Progressive or reaction progressive, so you can say. How about y-axis? Energy. Now this is your reactant for exothermic reaction, you know. This is called reactant side and this is your product side. I'm drawing this line. Alright. So you can see the energy of product lesser than the energy of reactant because the energy has been lost. Therefore the diagram looks like. You can see the potential energy from here. Here to here is bigger and this is smaller. Yes or no? So you can see this is the difference, you will get it. Let me just use the other color so that it is understood for you. Okay, this changes is known as delta H, enthalpy change we talk. Okay, enthalpy change is negative always for the exothermic reaction. And this is known as activation energy. Activation energy. Got it? It's your activation energy. Alright. Let me take methane. If methane burn in presence of oxygen, it produces water and carbon dioxide gas. Alright, this equation can be written. However, the profile diagram for endothermic reaction is just absolutely opposite of the diagrams. Okay, because in endothermic reaction, heat energy is being absorbed, so product has be higher energy. How it can be done? This is your reactant, for example, and this product has to be larger, so larger means above the reactant. Okay. Now drawing the line here, the peak, you can see here, this is your reactant. For example, nitrogen, you react with oxygen, you will get nitrogen oxide. Okay, let's say 2 nitrogen oxide. Alright, so now in this case, you can find what is the enthalpy change. This is your enthalpy change. Energy change also you can say. Alright, so energy change is always positive in case of endothermic reactions. How about the activation energy? This is your activation energy. Activation. Is it clear to everyone? Clear? These are the two diagrams. Okay. Remember, exo means exit, mnemonic. Endo means enter. Okay? It should be exiting, energy has to exit. Endothermic means enter. Energy will be entering here. The sign you remember, negative is for exothermic reaction and positive for endothermic reactions. Okay?
Okay.
So in the next class we will discuss about bond breaking and bond forming. Okay? Real world applications for exo and endo also will be discussed in the next class. Alright? Okay? Okay, you may leave now. Thank you.
Thank you, sir.
Yeah, thank you, sir.